Hello everyone. Welcome to Anupam Tech Talk. This is episode number 20 of my engineering leadership series. Today we are going to talk about something every software engineer eventually encounters: performance. We all want our applications to be fast, but there is an important question. When an application is slow, how do you know what to optimize? One of the biggest mistakes we can make is to start optimizing based on assumptions. We see something that looks slow, we guess what's causing it, and we immediately start changing the code. But good performance in engineering starts with very simple principle: measure before you optimize. Do not optimize based on assumptions. Imagine a mobile application takes 5 seconds to display a screen. An engineer might immediately think the API must be slow. So they start optimizing the API. But what if API actually takes only 300 milliseconds? What if the real problem is that the application is making 10 API calls sequentially? Or maybe the application is doing expensive processing on the main thread. Or perhaps a large image is taking too long to download. Without measurement, we are simply guessing. And optimization based on guessing can waste a lot of engineering time. We need to find the bottleneck. Performance problems usually have a bottleneck. The important question is, where is the bottleneck? It could be the network, it could be the backend, it could be the database, it could be the memory usage, it could be the CPU usage, or it could be something inside the client application itself. That's why monitoring and profiling are so important. Instead of saying the application feels slow, we want to turn that statement into something measurable. For example, the API response takes 2.5 seconds, or the screen rendering takes 800 milliseconds, or the database query is responsible for the most of the response time. Now, we have something we can work with. Let's take a mobile application as an example. Imagine a home screen displays a customer's account information, recent transactions, and personalized recommendations. The screen takes 3 seconds to load. We could immediately start rewriting the UI, but instead, let's measure the complete flow. We discover that application is making 6 API calls down the line. 4 of them are independent and could potentially happen in parallel. One API call returning much more data than the screen actually needs. Another API is performing an expensive database query. Now we have several potential optimization opportunities. We could reduce unnecessary data. We could improve the database query. We could parallelize the independent requests, and we can measure the result after each change. This is how more effective this is much more effective than simply rewriting code and hoping that the application becomes faster. Optimization has a trade-off. There is another important point: performance is not the only thing that matters. Sometimes we can make something faster, but make the code significantly more complicated. Maybe we can save 50 milliseconds by introducing a complex caching mechanism, but if that caching mechanism creates a consistency problem and becomes difficult to maintain, is the optimization really worth? That's an engineering trade-off. We should always consider performance, complexity, cost, reliability, and maintainability. The fastest solution is not necessarily the best engineering solution. Optimize what matters most. Another mistake is optimizing things that users do not actually care about. Suppose we spend 2 weeks reducing the internal optimization from 100 milliseconds to 50 milliseconds, but the customer is still waiting 3 seconds for the screen to appear. We may have improved a metric without improving the actual user experience. That is why performance should ultimately connected back to user and then business. Ask what is actually slow, who is affected, how much does it matter, and what improvements will create a meaningful value. As engineers become more senior, performance optimization also becomes a decision making problem. You may have a limited engineering capacity. You cannot optimize everything. So you need to identify the problem that matters most and invest your team's time accordingly. That, that is where engineering judgment becomes important. Measure, prioritize, optimize, measure again. This creates a much more disciplined approach to performance. So here is today's takeaway. Do not optimize because something looks slow. Measure it, find the bottleneck, understand the impact, make the smallest effective change, and then measure it again. Performance engineering is not about making everything faster, it's about making the thing that matters faster. Thank you for watching episode number 20 of my engineering leadership series. I would love to hear from you what what's the most interesting performance problem you have solved in your engineering career. Share your experience in the comment. Until next time, one lesson every day, better engineering, better leadership.